in this video, I'm going to do all of the even questions. In the last class, I did the odd ones, so if you have a question about one of the odd numbers, you can go check out that video. We're going to do the even ones together. So 8.1 is kind of just all types of series and sequences, nothing specific, so it's neither arithmetic or geometric, even though we may see some arithmetic and geometric ones in here, but there's no specific sequence and no specific formulas that we need from 8.1. So let's take a look at 4 and 6. So in 4 and 6, we just need to write the first 6 terms of the sequence. So we're just going to plug in 1, 2, 3, 4, 5, and 6. So we have 1 squared minus 5, 2 squared minus 5, 3 squared minus 5, 4 squared minus 5, 5 squared minus 5, 6 squared minus 5. So this would give us negative 4, negative 1, 3 squared minus 5 would be 4, 4 squared minus 5 is 11, 5 squared minus 5 is 20, and 6 squared minus 5 is 31. So these would be the first 6 terms of our sequence. Nothing too crazy. Make sure you show your work for questions like these. For all of these questions, I need to see your work. Alright, we're going to skip 6 because same thing, just plug in 1 through 6. So let's take a look at number 8. So we have to describe the pattern, write the next term, and write the rule for the nth term of the sequence. So first thing we want to do is write the rule. So what are we doing to go from 1 to 3? Multiplying by 3. And from 3 to 9, we're multiplying by 3. 9 to 27, multiplying by 3. So to write our rule, what would that be? So just to refresh our memories a little bit, I'm going to do that on the side. If we add from one number to the next, so let's say we add 2, add 2, add 2. To write our rule, that would be 2n. If we multiply from one number to the next, so let's say we multiply by 3 times 3 times 3 times 3. Our rule would be 3 to the power of n. So that's when we are multiplying from one number to the next. 3 to the power of n. We could also see a sequence that looks like 1, 4, 9, 16. What's special about a sequence like this? The next number would be 25. They're perfect squares. So a sequence like this would be n squared. If we had one that was like 1, 8, 27, 64, this would be n cubed. So these are common sequences that you could see when coming up with the rule. So let's go back here. We are multiplying by 3 each time. So how do we write our rule? Three to the power of n, but we start with 1. So if we plugged in 1 here, that would be 3 to the power of 1. And 3 to the power of 1 is just 3. So we have to do something different than just 3 to the power of n. N minus 1. Perfect. Because that way if we plug in 1, we have 3 to the power of 1 minus 1, which is 3 to the power of 0. What's 3 to the power of 0? 1. So that works. So this is our rule. All right, let's look at 14. So whenever you have a fraction, you just want to take it one step at a time. So look at your numerators, then we'll do the denominators. So with our numerators, what do you think is going to be in the numerator of our rule? If each time, no matter which term it is, our numerator is 3. What's going to be in the top of our rule? So what should be the top here? 3.
Some fractions, like when we read our rule, does it always have to be like written as a fraction?
Yes, because whatever's on the top, like you're going to treat it as if it were 2 different sequences. Whatever's on the top goes on the top. Whatever is on the bottom goes on the bottom. So we are multiplying to get from 2 to 4. We're multiplying by 2. Oh, we are actually adding 2 here. Adding 2, adding 2, and adding 2. So how do we write our rule if we're adding 2 each time? Go back to here. What did we say? If we add 2 each time, how would we write our rule? 2n. So 3 over 2n. Perfect. Yep. So let's look at 10. So on the top, we have 1, 2, 3, and 4. What did you get for the numerator? Awesome. Negative n. Because for our first term, second term, third term, fourth term, it is that same number. But they're all negative, so we put the negative there. It doesn't matter if you have a negative with the n or just a negative out front, same thing. And then what do you get in the denominator? Just 7. If you have the negative on top, you don't need it on the bottom. Good job. All right, and let's do number 12. So on the top here, we're multiplying by 3. So how would we write that in our rule here? We're multiplying by 3 each time. So 3n, because if we plugged in 1, we would get 3. So you don't need that minus 1 here because we start with 3. Well, let's see. So we just did the top. Now let's look at the bottom. We are adding 1 each time. So when we are adding a number, go back over here. When we're just adding, that would just be that number times n. So how would we write that on the bottom? It would just be n. Perfect. It would be 1 times n, which is just n. All right, let's look at number 20. So we're doing the same thing for these, but these are summations. So we still have to come up with our rule. We're going to start with I is equal to 1. And let's see, in our numerators, everything is 1. So how would we write that in our numerator of our rule here? What would go in the numerator? 1. Thank you. In the bottom, we're multiplying by 5 each time. So how would we write that in our denominator here? Go back on the side over here. When we're multiplying by the same number, how do we write that? So if we're multiplying by 5. 5 to the power of n. Perfect. And then what goes on the top of our summation up here? The first term goes on the bottom, but the last term goes on the top. What's our last term here? How many terms do we have? Infinity. And actually, instead of n, this should be an I, but it's the same thing. If you put an n, no big deal. All right, let's look at, we're doing the even one, so 22. So you have to find the sum. When you have a small number here, it's easiest just to plug in your first number through your last number. So we're going to plug in 1, 2, 3, and 4. So you have 3 times 1, 3 times 2, 3 times 3, and 3 times 4. So this would be 3, 6, 9, 12, and then we just add them all up. So 3 plus 6 plus 9 would be 18, plus 12, this would give us 30. So whenever you have the summation, that just means you add. All right, let's look at 26. So again, we have a number up here that's not too big. So we're just going to plug in 1 through 6. 1, 2, 3, 4, 5, and 6. So we have 1 squared minus 3, 2 squared minus 3, 3 squared minus 3, 4 squared minus 3, 5 squared minus 3, 6 squared minus 3. 1 squared minus 3 is negative 2. 2 squared minus 3 would be 1. 3 squared minus 3 is 6. 4 squared minus 3 is 13. 5 squared minus 3? 22. And 6 squared minus 3? 33. What do you get when you add them all up? 73. Any questions from 8.1? All right, let's move on to 8.2. So there's 2 formulas we need to know for 8.2. These are arithmetic sequences. To find our rule, we have a sub n is equal to a sub 1 plus n minus 1 times d. And then to find our sum, we have s sub n is equal to n times a sub 1 plus a sub n divided by 2. So a sub 1 is always our first term. D is our common difference. N is our number of terms. And a sub n is our last term. So in 2 and 4, we just have to tell whether the sequence is arithmetic. So what are we adding to get from 0 to negative 4? Negative 4. So we're subtracting 4. Are we subtracting 4 to get from negative 4 to 8? Yep. And yep. And yep. So is this arithmetic? Yes. And what's our common difference? Negative 4. Let's look at number 4. Anytime we have fractions, we want to make our denominators the same to see what's going on in our numerator. So to make this 5 a 10, we have to multiply the top by 2, the top and the bottom by 2, so this would be 6 over 10. Same thing with this, would be 12 over 10, and then this one would be 15 over 10. So our denominators are all 10 now. What are we doing in our numerators to get from 3 to 6? Add 3. What about from 6 to 9? Add 3. And 9 to 12? Add 3. So what's our rule? Or what's our common difference? But what about our denominator? 3 over 10. Are these arithmetic? Yeah. Because it's this, we're adding the same thing each time. And that same thing is 3 over 10. Any questions here? All right, let's do B. So we have to write a rule for the arithmetic sequence with the given description. So to come up with our rule, we have a sub n is equal to a sub 1 plus n minus 1 times d. So a sub n is equal to, what's our first term for d? For b, what's our first term? For b? First term. 8. Negative 8. Plus n minus 1. What's our common difference? 10. So we just want to simplify this, make it look a little bit prettier. We have a sub n is equal to negative 8 plus 10 n minus 10. Can we combine any like terms? Yep, negative 8 and negative 10 would give us negative 18. So this is our rule. And that's all it asks for here. It's just the rule. This is B for number 5. Any questions on that one? All right, let's look at 6. Again, we are writing our rule. So we have a sub n is equal to a sub 1 plus n minus 1 times d. So a sub n is equal to, what is our a sub 1? What's our first term? 37. Plus n minus 1. What is our common difference? Perfect. We're subtracting 8 to get from one number to the next. So negative 8. So distribute. We have 37 plus minus 8n plus 8. Combine like terms. Negative 8n plus 45. This is our rule. Now it asks us to find the 20th term of our sequence. So how do we find the 20th term? Plug in 20 for n. So a sub 20 minus 8 times 20, or times negative 8. Negative 8 times 20 plus 45. Negative 8 times 20 is negative 160. And negative 160 plus 45 is negative 115. So that is our 20th term. Let's do number 8. So what is our a sub 1? What's our first term? 0.2. What's our common difference? What are we adding to get from one number to the next? 2.1. So plug everything in. We have a sub n is equal to a sub 1, which is 0.2, plus n minus 1 times d, 2.1. Distribute. 0.2 plus 2.1 n minus 2.1. So 2.1 n. 0.2 minus 2.1 is negative 1.9. So this is our rule. And how do we find the 20th term? Plug in 20 for n. So 2.1 times 20 minus 1.9. We get a sub 20 is 40.1. So when it's arithmetic, you use this formula. So when you're adding to get from one number to the next. So just be careful. These two formulas are arithmetic. We have two different formulas when you're multiplying to get from one number to the next, which is geometric. All right, number 10 we can skip. Don't worry about it. I think the mistake is down here. Oh, they distribute wrong. That's what it is. Any questions on arithmetic? All right, let's go to geometric. 8.3. So in geometric, we have two new formulas. To find our rule, we have a sub n is equal to a sub 1 times r to the power of n minus 1. And then to find our sum, when we have a geometric formula, a geometric sequence, our formula is a sub 1 times 1 minus r to the power of n over 1 minus r. The only new variable we have here is this r, which is just our common ratio. Anybody remember how we find r? Second term divided by the first term. So that's the quickest way to find r. So in 2 and 4, we have to tell whether the sequence is geometric. Are we multiplying by anything to get from 162 to 54? Remember, to find r, whatever you're multiplying, just divide the second one by the first. So 54 divided by 162 is 1/3. So we're multiplying by 1/3. Are we multiplying by 1/3 to get from 54 to 18? Yes. What about 18 to 6? Yes. And 6 to 2? Yes. So is this geometric? Yes? Yes. Yes. What's your r? 1/3. All right, let's look at 4. So are we multiplying by anything to get from 5/3 to 10/3? 2. Multiplying by 2. What about from 10/3 to 20/3? Times 2, times 2, times 2. Is this geometric? Yes. And what's our r? 2. Perfect. All right, let's look at 5b. So to write our rule, it's a sub n is equal to a sub 1 times r to the power of n minus 1. Remember, it's just the r that gets that exponent. So for 5b, what's our a sub 1? $62. And what's our r? 1/2. And that's the power of n minus 1. And that is our rule. Any questions on that one? Number 6. So again, we're writing the rule and finding a sub 7. So first we want to find our r. To find r, just divide the second term by the first one. We get 2. So we're multiplying by 2. And what is our a sub 1? 9. So to plug that into our formula, we have a sub n is equal to 9 times 2 to the power of n minus 1. So to find our 7th term, what do we plug in for n? 7 minus 1. So we have 9 times 2 to the power of 6. Be careful with these that you follow your order of operations. That's a common mistake. So 2 to the power of 6 is 64. 9 times 64 is 576. So that is our 7th term. Any questions for number 6? All right, let's look at 8. So what are we multiplying to get from one term to the next? We can always take our second term and divide it by the first one. 6 over 5 divided by 3. Keep change flipped. Simplify. So 2 over 5. So times 2 over 5 times 2 over 5 times 2 over 5. So that's our r. What's our a sub 1? Our first term. 3. So 3 times 2 over 5 to the power of n minus 1 is our rule. Now to find the 7th term, what do we plug in for n? 7. So 3 times 2 over 5 to the 6th power. We can put that all into our calculator. 2 over 5 to the power of 6 times 3. That gives us a sub 7 is equal to 0.01228. All right, for the bottom part, find the sum. So this is questions from 8.2 and 8.3. We are using our sum formula. So the one that we have up here, this is our sum formula. This one is when it's geometric. You can tell that an equation is geometric when you have an exponent. When it looks like this, geometric. So out of 15, 16, and 17, which ones do you think are geometric? Which ones have an exponent? 16 and 17. So these two are geometric. So our sum of our arithmetic sequence formula is S sub n is equal to n times a sub 1 plus a sub n over 2. So this is our number of terms, our first term, and our last term. So we plug in 1 to n to find our first term. So 3 times 1 plus 5 is 8. That's our a sub 1. We plug in our number up top to find our last term. So a sub 9. So 3 times 9 plus 5. 3 times 9 is 27. 27 plus 5 is 32. So S sub n is equal to, how many terms do we have? What's our n? 9. Times 3. Oops, just kidding. Times, plug it in. So we have 8 plus 32 over 2. So 8 plus 32 is 40. Divided by 2 would be 20. 20 times 9. 20 times 9 is 180. So the sum of our 9 terms are 180. Now you can sit here and plug in 1, 2, 3, 4, 5, 6, 7, 8, 9, and add them all up. But if you had something with 20 terms, that would take you forever. You don't have time for that on the test. So you need to use the formula. Any questions here? All right, let's look at our geometric one. So our geometric formula is S sub n is equal to a sub 1 times 1 minus r to the power of n over 1 minus r. So we need to find our a sub 1, which is our first term, so we plug in 1 to our variable. So we have 11 times negative 3 to the power of 1 minus 2. This would give us 11 times negative 3 to the power of negative 1. What does the negative exponent do to our number? Puts it under 1, so it turns it into a fraction. So that negative 3 is going to go on the bottom of 11. And my pencil just gave out again. Super. Almost done. So a sub 1 is equal to 11 over negative 3. What is our ratio? What's r? Negative 3. R is whatever's touching that exponent. And then how many terms do we have? 5. So let's plug everything in. We have s sub n is equal to 11 over negative 3 times 1 minus r, which we said was negative 3, to the power of n, which is 5, over 1 minus negative 3. So first thing we want to do is that exponent, negative 3 to the power of 5. So we get 1 minus negative 243. When you have a negative minus a negative, it turns into a plus. You guys can also use your calculator on the test, so your calculator will do this for you. 1 minus negative 243 gives you 244. So 11 over negative 3 times 244. And then 1 minus negative 3 turns into 4. So 244 divided by 4 times 11 divided by 3, negative 3, gives you negative 223.66. So that's the sum of our 5 numbers. Sure.